Namaste everyone. In this video we're going to solve some problems, and those problems are on orthographic projections. So go straight away to our college Moodle site and then open this. Okay, so let me just turn it off. So this is how you will be able to see it. Just try to open it and then go inside the notes. So this is where you will be able to see all the 3D models. The 3D models in 3D interactive models you will be able to access from here. And these 3D interactive models will be helpful to you in completing the problems. So you can see the last page of this book. If we go there, you will be able to see all the 3D models. So links to these 3D models have been kept here. So when you click on this, it will open up in a new page, and the 3D interactive model will be now accessible to you. It will take some time to open up, and once it's open, you will be able to play around with it, and you will be able to see the different views. You can go with the top view, you can go with this left side view, you can go with the front view. Okay. So all these views you will be able to see. If you want to see whether there are any hidden edges, you can click on this button over here, and then shaded with hidden edges can be chosen. And now you can see light white colored lines are appearing for hidden edges. Okay. So wherever hidden edges are there, they are being shown by very light white color lines. So when you go to a particular view, you will be able to see which edges are hidden. So you can just click on that, and when you come back, you will be able to see why that line is hidden. So like that, you can use this model to understand perfectly how the model looks from different directions. But once you have done that, you should come back to orthographic projections and start solving the problem. So let me go for problem number 6. So click on start the quiz, and this is where you will be able to get all the details. So you can see here all the dimensions have been given here. This length height is A and this length is B. So now the values of A and B will be given differently for all the students, and it will change even if the same student attempts this quiz 2 times. So there is no time limit on solving this particular problem. So whatever questions you solved, after that, if you feel like you want to discontinue or you want to clear your other doubts before coming back to the question, you can do that very easily. Just select the options for this question. A diagram which is provided here, because it is 30 degrees on both the sides, it is definitely isometric view. And isometric view can also be called as orthographic view, because the projector lines will be perpendicular to the plane of projection or the reference plane. Then there are some questions here like how many hidden edges are there in front view. So you can use this to understand. Fine. So you can see in the front view there is only one white color line, and that's coming from here. So like that, you can check how many hidden edges are there. But of course, in the final exams, you will not be given these 3D models, and you are supposed to be able to find out the hidden edges from this diagram alone. Okay, so I guess I chose a wrong diagram here. So let me go back and so let me go to the notes and the last page of the notes. So open this, click here, 3D interactive models, and this is the model which we are doing right now. Let's go to that model and try to solve it out. So let's now go back to our question number 6, continue the last preview, and you can see whatever answers I had marked, I think they're gone, but I think for students that will be saved, so there won't be any problem. Right, so this way you can go ahead, and now we need to identify the hidden edges. So let's go for hidden edges. I will just show for the front view. Remaining 2 you'll have to deal with it yourself. So front view, actually for this particular problem, you can see the arrow, it is shown from this direction. So we'll have to see this view. So this, even though it is showing up as right view here, but for our problem, according to the given problem, you can see the arrow that is marked here, that should be considered as front view. So this is the front view for the problem. And here we can see that there are a total of 4 hidden edges. There are a total of 4 hidden edges. So that's what you need to select here. The hidden edges in front view, you need to select as 4. Same way, we have to identify how many hidden edges will appear in top view and the right side view. So you do that on your own. Then which of the faces are visible in the front view? So for this, we'll have to come back to our image. You can see all the faces have been given some names. So this is D, this is M, this is K, this is C, E, and so on. So we'll have to identify which of these faces will be visible in the front view, which is defined by this arrow. So let's go back here and see. So yes will be visible, C will be visible, and I guess those are the only two visible. D will be perpendicular, M is perpendicular, K and E also are perpendicular. So C and yes are the only two faces that are visible. So C and yes. If you want, you can of course go back here and see which of these faces are visible. So when you see the front view, you can click on the faces that are visible, and when you shift back, you'll be able to see which faces they were. Right? So these faces were not at all visible, and hence they will not be visible. Of course, we can just hide the hidden edges if you feel like it. So this way you can find how many faces are visible and which faces are visible. So you can go ahead and do the same for the top view and right side view. I'm not going to do that in this particular video. After that, we're supposed to find the area of the front view, of the top view, of the left side view, and of course so there is one small question here: which of the areas and perimeters are not affected by the length A? So A length, you can see it's given over here. A length is the height. So where A value, when we change it, which value is not going to be affected? So the answer to this is obviously the top view, because A length will not be visible at all in the top view. So for this, I'll have to select the top view. Same way, there is one more here. So you can see for B, if you change the value of B, which of the views are not affected? So you can go back here and see which of the views are not affected. So if you want to see height, you can see that when you go to the height is not at all visible here, and that's the reason why this the value of A will not affect the area and perimeter of the height. Same way, you might have to find out which value is unaffected by the value of B. So you can do that. So let's go ahead and find the area. And so I'm just going to solve the particular this full problem, and I'm just going to keep it aside. Okay, and AutoCAD window, I'm going to keep it this side. And, let me see here. So both these side by side, I can keep them and I can start drawing it. So this legend and all, we will not be needing them. So let's push it out for now, and we just need these to apply the properties. So now that we're ready to start drawing, let's start. So press F8 for ortho. Ortho should be on. And because you can see that the arrow is pointing slightly towards left, front view should be appearing on the left, and on the right side we should keep some space for the left side view. Right, we are watching it from the left side, and that left side view is going to appear on the right side. So let's begin drawing this. Okay, start the front view. So this is the space in which we'll be drawing the front view. So let's go ahead and see what are the dimensions which are visible. So let's start with the line, and you can see that I'm shifting from end to midpoint directly. I cannot click anywhere in the middle. That is happening because even though the object snap is on, the option nearest has not been selected. So you'll have to just click on this arrow and then click on the nearest button. And now when you take a line command, you can see I can start clicking on it at any point. So click on it at any point. Then let's go up. You can see the upward distance is 18. So let's take 18 from keyboard. Just expand this a little so that it takes full screen space. Okay. And now that 18 distance has been taken, we want to move right side. That distance is 56 over here. So let's go ahead with 56. And then we want to come back. After that, we want to go horizontal, that is length 12, and then we want to move up by a distance of 6. So let's take 6 upwards, and then left again. So that distance has been given as 32. So let's go 32 on the left side. So then take it perpendicular here and join it. So one thing you can notice here is whatever lines are at 30 degrees on the right side, they become horizontal in the front view, and whichever lines are vertical in the isometric remain vertical here. Okay. So that's a small hint that you can use for understanding how it happens. So once you are done drawing it, you can apply this properties. Fine. So solid properties you can take and apply. So all the visible edges need to be shown as solid edges. So that's why we are doing it over here. So this is the base. Now we need to draw the face C and this cylindrical face over here. So for that we need to take some reference points. So we know the length of B, it is given as 100 mm. So from this edge we have to take an offset of 100 mm. So let's go ahead, take it, go enter 100, enter, click here and click on the right side. So at that point we have the axis of the cylinders. And then from the bottommost line we can see that the height of the topmost line is at a distance A. So that means from this line at a distance of A we are going to how we will get the topmost point. So let's go ahead. So A length has been given as 63. Let's go ahead and take it. So O enter, 63 enter, click on this line and click above. So this line is appearing at 63 length and this line is appearing at 100 mm from this line. So we need the intersection of these two, and that intersection will be the axis point for the cylinder. Let's go ahead and do that. So let me extend it, EX double enter and click on this line to get the axis. Now because this is axis line, let me take the axis style and apply it over here. This is the top line, and from this we'll have to draw the diameters. So you can see 36 is the diameter for the outer cylinder. So I'll have to take offset of half of 36, which is 18. So 18 on the right side, and then for the smaller circle you can see 22 is the diameter, so half of that we have to take on both sides. So 22 by 2 is 11, so 11 on both sides. So now mind you, this line I have drawn, but on the other side I have not drawn that line, and there is a reason for that. A reason you will understand in a moment. So let's select whichever edges are visible to us. So this edge is visible to us. This is the topmost edge, will be visible. And then okay, so let's take this at 36. That's where this line will bend over and join this particular corner. So from the axis, okay, so these two lines, they will be hidden because they represent the inner cylinder. So let me take the match properties, MA enter, take hidden edge property and apply on these two edges. It's fine. So now from here what I'll do is I'll trim this off, and then from the axis I need to take a distance of 36 in the left side direction. So O enter, 36 enter, click here and click on the left. Then this point I need to trim it off, and then take line, L enter and join these 2 points. So this edge will be a visible edge, so let me make it solid line like this, and then we can see the height of the cylinder is 25 from the top. So let's go ahead and take that height. So O enter, 25 enter, take it 25. Then I need to trim it, TR double enter, trim all these edges, and at some place here this edge is going to be joined over here. So for that I'll have to take the same diameter, that is diameter 36. Let's go ahead and take that. So O enter, 36, that is 36 is the diameter, so half of that we have to take, which is 18. So O enter, 18 enter and take the offset, trim this, and then this point we'll have to join over here. And here we will of course get an edge here, and so you can see that when we are drawing it we will get an edge here. So that edge we will have to show. Fine. So match properties, solid, this need to be solid and this as well needs to be solid. So next we will have to draw the holes over here. So for the holes we can see the length has been given as 28. That is the length of axis line from this particular edge. So let's go ahead, O enter, 28 enter, click on this and click to the right side. So this line is the axis. So let me match the properties, MA enter, click on this and then on this. You can move it slightly up so that axis line appears like this. For this line as well we just need to move it up and also reduce this a little right, so that it is enough till here. Now we need to show the holes. They will show the two hidden edges will actually come over here, which will be the silhouettes of the cylinders. Silhouettes of the cylinders. So O enter, and the diameter of this, you can see it is given as 12. So we'll have to take half of that on both sides, which is 6. So O enter, 6 enter. Click on this, click right, click on this, click left. Then we need to trim. So 3R double enter, click on these two, and these are hidden edges because we won't be able to see from here. You can see the holes are not visible, but when we turn on the hidden edges, you can see there are two white lines appearing over here. So that's the reason we need to show those as hidden edges. So match properties, okay, match properties, you may enter, click on this and apply those properties on these two edges. So this completes our front view. So you can see that there are 4 hidden edges over here. These are axis lines. They need not be counted as hidden edges, and they need to be shown here like the axis line is supposed to be. And then there are all these kind of things. So finally, if you want to come over here, and if you want the area, we need to find this particular area. So let's go ahead and find this area. So let's copy this outside, okay, and then okay, you can delete the axis lines and draw a rectangle by REC enter, or you can take the rectangle from here and draw a rectangle which encloses our front view. So this is so that we can create an outer boundary for this, right? So type BO double enter, which is command for boundary, and then we can click on the inside here and press again an enter button. So when you do that, you can see an outermost boundary has been created. So when you move it out, you can see our visible edges and all the properties which we had drawn earlier, they are present as separate entities, whereas this one has been created as a single entity. Right. So this single entity, if I do undo and bring it back, this will help me in finding the area. So type double enter, double A, double enter, then click on this object, and here you will get the area. So that area, and I just feed it in here. So 3940. And once I'm done entering all these values, I just need to finish my attempt. It'll ask again, and it'll ask you to verify whether you have done the complete answer. So if I have not answered all the questions, it'll ask me, it'll tell me that yeah, so you have not completely answered this question. And if you're still satisfied with it, if you want to go ahead with this, you can just submit all and finish. After this, it's going to display how many marks you got and how those marks were distributed. So you can see here I got complete 2 marks. So and here I got this correct, this I didn't select at all, so I'm not getting any marks for that. Here I've got complete marks again. Here I didn't get because I didn't mark any of them. Then again here, and you can see this answer is also wrong. I don't know why. It's not supposed to be wrong. It's way different from what it's supposed to be. So maybe I'll have to check this, and I'll do the correction and post this question once again for you to solve it. Fine then. So this is how you're supposed to solve it. The other 2 views I hope you'll be able to do on your own, and this is where I'm going to stop. So hope you have enjoyed this, and hope that you'll be completing this problem number 6 as a part of your assignment. And all these marks, as I have always kept telling in the class, will be considered as assignment marks, and they will become a part of your final marks. Right. So all the best for solving this, and goodbye for now. We will see you in another video wherein we'll be taking up another problem and